Hello and welcome to my talk, Multi-Platform Development with FireMonkey. My name is Anders Ohlsson. I work here at Embarcadero in the Developer Relations Department. So, with RadStudio XE2, we introduced FireMonkey, the next generation business application platform. Using FireMonkey, you can create stunning HD and 3D business applications on both Windows and Macintosh. FireMonkey, of course, uses the native raw power of both the CPU and the GPU. You can, of course, as always, connect to any data and any service. So, web services, DataSnap, DB Express, all of these things are part of FireMonkey and the FireMonkey platform. Full suite of UI controls, all the controls that you've gotten used to are there in FireMonkey. Using live bindings, you can visualize your data in ways that you haven't been able to visualize them before. FireMonkey uses a styled vector UI without coding, so you can create your own custom styles, and everything is vector based. So no matter how far you zoom in, your rounded corners will still be rounded corners. You can communicate in FireMonkey using animations so that you can move objects around on the screen, but also animate bitmaps from one bitmap to another, going over some kind of transformation. You can add effects, filters. So FireMonkey is a business application development platform for application developers who want or need to create the most modern, visually stunning, and highest performance applications for Windows, Macintosh, and mobile. FireMonkey is a next generation platform that provides developers the fastest way to create native CPU and GPU powered desktop, mobile, and enterprise applications, and applications for multiple platforms. So here's a slide that tells us a little bit of what FireMonkey is not supposed to be. It's not like Java and .NET that run on software-based virtual machines and don't directly tap the performance and features of the powerful CPU and GPU underneath the hood. It's not like rich internet applications that are web-based like Flash and Silverlight, which are designed for web browsers and are powered by interpreted scripts or bytecodes running in software-based virtual machines. It's not like HTML5 and CSS3 frameworks, which are limited in capability, footprint, and performance. And it's not like 3D or 2D graphics frameworks, which are aimed at gaming and lack standard user interface, database, and services connectivity required for non-gaming applications. Here's a comparison between the VCL and FireMonkey. VCL, of course, is only available on Windows, 32 and 64-bit. However, FireMonkey is available on Windows, Macintosh, and iOS. FireMonkey is cross-platform, and like I mentioned earlier, it provides a modern, themed, or skinned, if you will, UI, real-time image and animation effects. We work with Direct2D, Direct3D, Quartz, and OpenGL, depending on the platform. It's all native Delphi and C++. And the framework is written in 100% Objective Pascal. On the Mac, FireMonkey uses Quartz, and the rendering for 3D on the Mac is done using OpenGL. On Windows, we use Direct2D for HD applications, Direct3D for 3D applications, and when Direct2D is not available, FireMonkey uses GDI Plus for HD vector graphics. FireMonkey controls descend from T-component, so you will recognize a lot from the VCL in FireMonkey. So again, FireMonkey takes advantage of the GPU whenever possible. An HD form can be rendered on a computer without a GPU with a few restrictions. You can't use a TVO port 3D, which is a component that allows you to host 3D components inside of a HD form. If you don't have a GPU, you can also not use shader-based filters because those require the GPU. Obviously, they require the massive parallel GPU to execute. A 3D form requires a GPU to perform sophisticated transitions and manipulations of the user interface. FireMonkey has a stylebook component. This component holds a style. It allows you to edit a style and manipulate the style, both at design time and runtime. FireMonkey styles are a collection of FireMonkey resource styles. It's a WPF type of implementation. Styles can be inherited, saved, and loaded. We include a whole bunch of styles in Red Studio XE2, including look and feel style files for Windows 7, Mac OS, and iOS, as well as other custom themes. A little bit on 3D programming. FireMonkey provides an object model to target multiple platforms. We use the right-handed orientation, as you can see here on the screen, X, Y, and Z axis. Hardware acceleration, as I discussed a little bit earlier, on Windows it's DirectX, on Mac OS it's OpenGL, and on iOS it's OpenGL ES. FireMonkey animations are used to modify property values over time. So for instance, if you wanted to change the opaqueness of an image, you could do so. Go from fully opaque to non-opaque over a certain amount of time. Animations run in a separate thread so that they are machine speed independent. Animations can be looped and or reversed. They can follow a variety of time value curves. You can have linear, or you can provide a path. Animations can be triggered by events such as mouse over, focus, visibility, etc. A lot of the properties are animatable. So for instance, here we see height is animatable. You can set it in the object inspector and create an animation at design time if you want to as well. Effects and filters. The GPU effects and filters can be applied to bitmaps and controls. They can also be triggered by mouse over, focus, visibility. So for instance, if you wanted to highlight a specific section of your UI, you can do so with an effect or a filter. If you wanted to, let's say you provided a search capability for your UI, you could highlight the specific parts of your UI that matches the search, and you can defocus or gray out or even blur the other parts of the UI so that people can find what they're searching for visually. FireMonkey is a platform that supports and abstracts the RTL, the graphical user interface, database connectivity, and the operating system. So all the things that you're used to from the VCL are actually part of the FireMonkey business platform. So whether it's DataSnap, DB Express, or the visual controls, or anything else that's in the RTL as well. So let's take a look at a couple of demos. We'll go into Rad Studio, and we'll bring up the image spinner project here first. So here's a really simple application. It is a HD application. It has a T-image control on the form, and I've loaded a flower into it. I have a timer here, and on the on-idle event, I compute how much time has elapsed since the last time I was triggered, and then we're going to update the rotation angle of the image. We're also going to compute the frames per second, and we're going to put that in the caption of the form. So let's run the application, see what happens. I'm going to run it on Win32 here first. So here's my application running in my virtual machine on my Macintosh hardware. So I get about 40 frames a second. If I make it larger, you see the frame rate goes down to somewhere between 5 to 10 to maybe 15 tops. You notice that the rotation speed is the same as it is here, and that's because I have my game timer logic, if you will, built in here as well. You'll notice that I'm doing the updates myself in this application. I'm not using FireMonkey animations. We'll see demos with that a little bit later on. Now let's go and run this on the Macintosh. So I'll hit run, and it's going to deploy the application to the Macintosh, and here it is as a Macintosh application. You can see that the frame rate is a lot higher on the native hardware for this HD application, about 90 frames a second here. If I go full screen, I'm looking at about 20. All in all, the application works exactly the same on both Windows and Macintosh. Let's take a look at a different application. I have the GPU shader demo here. So we're going to run that. Here we can do different effects. These are GPU shader effects. So we can blur the image using different blurring algorithms here. You can change the color, go monochrome for instance, a black and white picture. Here's my favorite. You can do magnification, and here you'll see things that you couldn't do on the CPU. The GPU makes this these kinds of smooth animations possible. My absolute favorite is the ripple effect. You could write something that drops a rock in the water and changes the ripple effect and makes it look like you actually dropped a rock into an aquarium or something like that. Let's take a look at my bouncing spheres demo here. So in the background here, I have basically, let's run this first, and we'll see what it does. So here's my spheres that are bouncing around in my virtual box here. I can rotate the entire world, and you see that the spheres are still spinning and bouncing inside of this virtual box here. I can stop the balls right here. I can start spinning them. You'll notice that this ball is spinning here independently of everything else. Now you see the large ball is spinning here. I can turn them on again, and they're still bouncing inside of this box. So let's take a look at the application in the designer. So here's my T-sphere. It has a depth and a height and a width, because it's a 3D object. It has a position, X, Y, and Z. It has a rotation angle that we're going to update when we're actually spinning it. We have the second sphere, the smaller sphere over here. We have 4 lights here that are all spotlights. They could also be set to being point lights and light the whole scene, like this, for instance. We have a couple of different planes. We have a back plane, a bottom plane, a left plane, and a right plane, and also a top plane at the top. These objects are all contained inside of a layout 3D. The layout 3D is a non-visual component that allows me to parent other controls to it. And in this case, when I'm spinning the entire box around, that's exactly what I'm going to do. I'm going to spin or rotate the layout 3D component as opposed to attempting to rotate all the other controls that are inside of it. I also have a text 3D component to visualize the frame rate. Finally, in front here, I have a T-layer 3D component. This is a component that I'm surfacing using the projection PJ screen so that it isn't sitting in 3D space. It's actually sitting flat against the screen, if you will, when I'm running my application. And in here I have all the controls that allow me to set the speed, rotate the box around the X, Y, and Z axes, as well as spinning the spheres and moving them around. So in the code, what we're looking at here is we have delta X, Y, and Z for each of the spheres. We have a frame rate counter. We keep track of the previous and the current time. When I'm running the animation, much like the other demo, the image spinner demo, I use my game timer logic here to figure out how much time has progressed since the last one, so that I can compute how much I'm going to animate in order to keep a constant machine independent speed. If I'm moving the large sphere, I'm going to update the X, Y, and Z components of the position. If I hit a wall, I'm going to reverse the delta X, Y, or Z. Same thing for the small sphere. If the distance between the center of the two spheres is less than 3, in this case the large sphere's diameter is 2, the radius is 2, and the small ball's radius is 1. So basically if they make contact, I simply assume that it's a perfect collision and that the balls weigh exactly the same amount, and I reverse both X, Y, and Z deltas for each of the spheres. If I'm spinning the spheres, I update the rotation angle, in this case the X, Y components for this one and the Y and Z components for this one. If I'm rotating the entire box, then like I said, I'm rotating the layout 3D, X, Y, and Z respectively. So you've seen this on the PC under Windows. So let's go ahead and run it on the Macintosh. And there it is running on the Macintosh. A lot brighter since we actually set one of the lights to be a point light as opposed to a spotlight. You still see the spotlight effect from the other lights that are in the scene here. Okay, let's go to the next demo, which is my grid slider. So here we're going to show different animations. Let's run it first and see what it does. Here, first on Windows. So we've got our different grids here. We also have a couple of live bindings. There's other sessions describing live bindings. So I have a live binding that gives me the length in inches of the fish in this edit box, and also represented here on the progress bar. So you see it's 7 here, it's 90. So this obviously goes between 0 and 100 at the end here. So animations, when I click on the slide button, it's going to animate. You wouldn't necessarily do this in a real application, but you could. So here we are doing some animations. In this case, what it does is it animates the height of the string grids from what they were before, which is 200. They were 200 high in the designer. We're going to go from 200 to 20 as far as to height and collapse them. It's going to take 1 second to do so. Right after that, after 1 second, we're going to take another second to move the Y position of the string grids. So the first string grid is going to move to the second position. The second is going to move to the third position. The third is going to move to the first position. And that's also going to take 1 second. After 2 seconds from the start of this code, we are going to expand the grids again. So we're going to go from 20, where it was, to 200, and that's also going to take 1 second. So the entire animation takes 3 seconds to perform. These are all loaded onto a thread, and they all execute in parallel, which is why we have to wait or delay the second set and the third set of animations in order to stack them on the timeline correctly. So again, this is what it looks like. At runtime, we collapse, move, and expand. Alright, we can also do animations at design time. So let's say, for instance, that I wanted to change the rotation angle here. Oops. The rotation angle. That's the animatable one right here. So, of course, I can set a rotation angle of 45 degrees or whatever. Now you notice my button is 45 degree angled. But what I really want to do is I want to add an animation here. Here's my animation. I'm going to set it to take 1 second. I'm going to enable it. I'm going to loop it. I'm going to start value of 0 and a stop value of 360. And this now should just animate the button over and over and over because it's looped. And here we go. Here's my spinning button. It still works. When I click on it, might be hard to hit it when I'm actually on the side here, which is why I'm clicking it in the center. Alright, let's run this on the Macintosh as well. So here we are. Here's my Macintosh application, working exactly the same as the Windows application. Speaking of the Macintosh, we can go in and look here what this profile actually looks like. You notice for Windows, it doesn't specify a profile, so it runs locally. But for OS X, I have a profile that tells it that it's going to go to my native Macintosh machine. This is the VMware host IP. There's a port number here, and there's a password, which is actually blank. On the Macintosh side, I'm running the platform assistant. Notice it's sitting on 64.2.11, and this platform assistant is responsible for making sure that I can deploy an application from Windows to it. This could be running on, in this case, on my Macintosh, but it could also run on a Windows 64-bit machine somewhere in the cloud or somewhere, wherever. It could be my neighbor's machine. It could be anywhere. As long as I have access to it and I can get to port 64.2.11, I can deploy to a remote machine, whether it's a Macintosh or a Windows machine. The platform assistant is also responsible for debugging, so remote debugging. It will react to your breakpoints and then let Rad Studio take care of the debugging for you. So you'll stop at the breakpoints, etc. Okay, let's go back to the slides here. But wait, there's more. Using FireMonkey, you can of course also create native iOS applications. You design the application using Delphi on the Windows side, and you export it to Xcode, bring it over to the Macintosh, and compile it in Xcode and run it on the simulator or on the iOS device, like your iPhone, your iPad, or your iPod Touch. So let's take a look at how that works. So let's actually create an application from scratch. We're going to create a FireMonkey HD application for iOS. So here we go. Here is my application for iOS. Let's take a image. Take a T-image control or a T-image object. Make it a little larger. Let's go ahead and load a bitmap in here. Take a bitmap, for instance, from, where are we going to take it from? We're going to take it from my pictures, sample pictures. Let's go ahead and pick this one. Okay, so there's my koala. Let's now add an effect to this image. So here's an effect. I'm going to pick a reflection effect. Now you see I have a reflection of my image. If I bring them together, it'll look a little better. There we go. Now let's say I wanted to do something more. I want to pulsate this effect, for instance. And let's do that with the opacity. Of course, you can set the opacity to 0 or to 1 or anything in between. But in this case, I want to create a float animation. Let's make it take 1 second. We're going to enable it. We're going to loop it. And we're going to go from 0 to 1. And let's see what that looks like. Okay, it doesn't look too bad. However, I probably should make it auto reverse. There we go. So now it's auto reversing. So now I have an effect and an animation. And an animation. So let's go ahead and save this project. I'm going to save it. I'm going to put it on my shared drive between my host and my VM. So let's create a new directory here. We're going to call it my iOS demo. I'm going to put it in here. Just going to save it like that. Project 1, that's fine. Finally, we're going to do DPR to Xcode. This gives me an Xcode project. I go over to the Macintosh side and launch Xcode. And I go ahead and open my project, which is going to be under Demos and under my iOS demo. In the Xcode directory, there's the Xcode project that was created by Rad Studio. Xcode is going to load it for me. I can run this on the iPhone simulator by hitting run. And up comes the simulator. And it's going to launch my project. There's my FireMonkey project. And there you can see exactly as I designed it. So in summary, FireMonkey is the next generation application platform that fully harnesses the powerful GPU graphics hardware, as you've seen in multiple demos with the last one that we did, for instance, on the iPhone, but also the GPU shader effects that we saw on Windows earlier. As you can tell, you can rapidly build visually spectacular applications. You can invest in one platform and deploy to numerous OSs. So in this case, your doing the development on the Windows side, you're running your applications on both Windows and Macintosh and iOS. In the case of desktop applications, Delphi and C++, both supported, both work the same. You can create Delphi and C++ applications that run on Windows and Macintosh. And you have access to fully programmable animations and effects. So with that, thank you very much. And now the best part, your questions, and hopefully I can answer all of them. Thanks.